Okay, section 1.7. This is the last section in chapter 1. This one's pretty short. It's all about special factoring, and this is where cubes are going to come into play. So it starts off on page 81. The only thing I really want to mention out of the book before we get to the example or the problem set is the how to factor a polynomial on page 81. And they give you 5 steps. My little note in the margin and what I stress in class is I mentioned to students to first look for the greatest common factor. See if you can pull something out of there first to whittle it down. Then if there's 4 terms, look at grouping. It's going to be a grouping problem if they give you 4 terms, unless for some reason one of those, well, no, you're still going to have 1. So if they give you 4 terms, plan on grouping. Then after that, look for any special factors. Look for the perfect squares, look for the perfect cubes. Okay, so with that said, let me switch the screen. Okay, there we go. So problem set 1.7, and I went ahead and wrote my little formula up there. You can do that. I mean, you can write it right in the book if you want to at the top of the problem set or on your notebook or whatever you're working on. Then it's right there to refer to, because it's one of those I don't expect you to memorize. If you do enough of these problems, you'll know it, but you'll probably still want to go back and double check. There's no shame in not memorizing perfect cubes and how to factor them. So let's get into 1.7. I want to do number 17 first. Number 17 says factor the following binomials as the difference of 2 squares. So what happens is they're telling you, but it'll get to a point later in the book where you need to look for these things. They're not going to tell you, hey, check it out, this one's perfect squares, look for perfect squares. They're not going to tell you that. So you want to know to find them, look for them. Now, the key is having 2. The special factor rules work if there's 2 perfect squares or 2 perfect cubes. So in this case, and just to write this down over here, just to help think about it, remember a squared is a minus a, 16 is 4 times 4, b squared is b times b. All you're doing is looking for anything that repeats. So I have a perfect square here, a perfect square, and a perfect square. So what I have is a perfect square minus a perfect square. So when I have that, remember, and I didn't write this down, we did this way back in section 5, I believe. We have a perfect square minus a perfect square. When we have that, I will put it right here as a reminder. When we have a perfect square minus a perfect square, that's when we know we have the plus minus. That's what I say in class because it's simple to remember. We have the plus minus situation. A perfect square minus a perfect square means a middle term dropped out. So we had a plus and a minus. That'll give us the negative squared b squared, second term squared. And it'll give us a positive and a negative for the middle, so they'll cancel out. So what we have is a minus 4b, a plus 4b. That's it, done. I didn't have to do any guesswork. All I had to know is what's the square root of a squared? A. Square root of 16 is 4. Square root of b squared is b. And I just plug them in. There's no guesswork. That's the nice thing about the special factors. The perfect squares, perfect cubes. There's a formula. You just have to plug numbers in, terms in. Okay, and we're done. You can check it. A times a is a squared. A times 4b is 4ab. Negative 4b times a is negative 4ab. They wipe out. They cancel out. They're gone. And then it's not a situation of a 1 remaining because you aren't multiplying. You are literally adding 4ab and you're subtracting 4ab. They're gone. 0. And then negative 4b times positive 4b is negative 16b squared. And it's done. Let's move on. 27. Number 27 said factor as difference of cubes, I believe. Factor the following binomials as the sum or difference of 2 cubes. 27 gives us x cubed minus 8. So what happens here, and I'm going to do this. I might be the only one. This is the only perfect cube that I'm going to do on the lecture. So what I'm going to do is write the corresponding formula down first. We know that, let me write the whole thing. I'll write the whole thing down. We know that when we have a perfect cube minus a perfect cube, our formula to solve, this is a minus. So I use, where is it? I use, whoops, I wrote the same one up at the top. I use the negative, the a cubed minus b cubed. And that one is a minus b, and then it's a squared plus ab plus b squared. All positives in that second portion. The negative is in the first portion. So I need to find an a. In this case, I'm looking for the perfect cube. So x cubed. Well, I know that a must be just x, because x times x times x is x cubed. Then our b is the cube root of 8. The cube root of 8 is 2. 2 times 2 is 4, times 2 is 8. So perfect cube, 8 is a perfect cube. Cube root of 8 is 2. So now I know these values, and I just plug them in. That's all I have to do. So my a is x. My b is 2. Then I have a squared. Well, that was my x squared. And then I have ab. So I take my a and my b and I multiply them. 2x. Then I have b squared. So I take my b and I square it. 4. And I'm done. That's all I have to do. This is why the special factors are so dreamy. Because here in 17, I was done. That's it. Plug it in. Here, I'm done. Plug it in. All you have to do is look and know. Look and know. Perfect. What's the square root of a squared? 16, b squared. I know those. I just plug them in. What's cube root of x cubed? And 8. Find them, plug them in. So let the special factors and their corresponding formulas do the work for you. Number 39 now. And we are almost done with chapter 1. Number 39. This says factor each by first factoring out the greatest common factor and then factoring the polynomial that remains if possible. And I don't think they give you any yet. They don't give you any in this section that aren't possible, like that one from the other section. That was mean. 2x squared minus 24x. Okay. So what happens here is we want to first look for the greatest common factor. And when we look through, we don't have any number there. We don't have a leading coefficient. So we know we don't have a numerical greatest factor. But we have an x cubed, an x squared, and an x. So my greatest common factor is x. So I'm going to pull out an x. When I pull an x out of x cubed, it leaves me with x squared. When I pull an x out of 2x squared, it leaves me with 2x. When I pull one out of 24x, I pulled the only x out. Now I have something that is factorable. I'm not going to make that green. I'm just going to go for it. Now, what I will do here is, these are the trickiest because it's a negative here. So we knew we had a negative and a positive. So we have many different combinations. We don't know for sure if we're going to have a positive and a negative, where they're going to be, what numbers are going with them. So when you have a negative third term, that's when you have the most work because you can't narrow it down. You can't eliminate one sign. So with negative 24, what I always like doing is I always go for the two that are the closest together, the two factors that are nearest each other. It doesn't always work, but it usually works, I will say. So what happens with 24, I'm not going to use 12 and 2. I'm not going to use 8 and 3. I'm going to try 6 and 4 to start with because it seems like it's most often the case. So I'm going to go this route. I'm just going to do this for now. I'm going to say, okay, I know I have plus and minus. So then I'm going to lightly just shade in here. Let me do it wrong first. So if I try 6 and 4 this way, I'm going to get x squared minus 4x plus 6x. That's going to give me a positive 2x. So I know that's wrong. So that one doesn't work. But I'm just going to leave everything as is, and I'm going to try them the other way. Now I have x times x is x squared. Then I have a negative 6x, positive 4x. The difference is negative 2x. That's my factor. That's my answer right there. So trial and error, but you can whittle it down. I start with the closest together. I get 24 and 1 is almost never going to be the answer. So start with the closest two and see what happens. Like I said, it doesn't always work, but it's a good starting point. So number 53 gives us a grouping. And they tell us use factoring by grouping to factor each out. And we have an x squared minus 3ax minus 2x plus 6a. Hopefully that's a lot to write. Hopefully I wrote it all down right. Again, they are guiding you. So they're giving you the answer basically of which method to use by giving you 4 terms. When they give you 4 terms, jump to grouping. And what I see here is I can pull an x out. I don't have a leading coefficient, so I can't pull a whole number out. I don't have an a here. I can't pull an a out, but I can pull an x out. When I do, I'm taking an x out of x squared, so I'm left with x. Then I am taking an x out of 3ax, so I'm left with 3a. Now here, again, I see that I can pull a 2 out. I can't pull an x out because it doesn't exist here. I can't pull an a out because it doesn't exist here. I'm going to pull a 2 out. Now I'm not going to write a value yet, because what happens is, I'm going to do this one like I mentioned earlier. I'm not even going to worry about factoring right now. I'm going to look and say, I know I can pull a 2 out. I need this or I'm done. So I'm just going to write it in there. And then I'm going to check and see, what do I need that 2 to be to make this work? 2 times x would be 2x. 2 times a negative 3a would be a negative 6a. So I need to make this a negative. When I make that a negative, it gives me a negative 2 times x is negative 2x. Negative 2 times negative 3a is positive 6a. That matches. So what I did is I just brought this one over right away. You don't even have to factor a 2 out right away. You can bring this over. If you're comfortable with this group, you say, yeah, got it. I know that's right. This is our last one. So you can turn it off if you have to, but I'm just going to do this again to show you the power of grouping. Let's say you feel very good about this one. And you say, sweet, yeah, let me double check. X squared minus 3ax, got it, that's right. You can immediately jump over here and say, how can I get that out of that? How can I get this quantity from here? And then that's going to show you, oh, I need a negative 2. And you can find it that way. You know it has to match. If not, you don't have a group. So once you get that, again, you're going to factor that quantity out. That's your greatest common factor. Yes, it's a quantity, but it acts as your greatest common factor now. You pull that out, and then you say, what am I left with? Well, if I pull it out of here, I'm left with x. If I pull it out of here, I'm left with negative 2. There's my answer. So don't let grouping throw you off. Don't let 4 terms throw you off. Look for the greatest common factor first. Can I pull anything out of there? If not, say, hey, look, oh my gosh, there's 4 terms. It's got to be grouping. And just group. Take the first greatest common factor out of the first group and then the second group and stick them together. Take the common factor out of that and just stick what's left over. All right. Hopefully you enjoyed that one. That was fun. It's only gonna get better from here. So hang with me.